Betelgeuse, also known as Bug-Jew, is a massive red supergiant star that, if placed where our Sun is, would extend all the way to Jupiter's orbit. It's enormous, unstable, and on the brink of exploding, one of the most powerful explosions of radio energy in the universe, generating more energy than a billion suns. The Sun, a brilliant ball of atomic fusion, sustains life on Earth and regulates the rhythm of our days and seasons. While it's hard to imagine any star surpassing our Sun, beyond our solar system lies a colossal phenomenon that makes even our mighty star seem insignificant: Betelgeuse. This red supergiant challenges explanation with its immense size, erratic pulsations, and unpredictable behavior. It has long fascinated astronomers, presenting mysteries that challenge our understanding of stellar evolution. Despite the star's enormity, scientists are still studying its power and potential, and recent observations have revealed something astonishing. Join us as we explore the Orion constellation with the James Webb Telescope to uncover how the discovery of Betelgeuse might revolutionize our understanding of the universe. Betelgeuse is one of the most recognizable stars in the Northern Hemisphere's winter sky. Located in the Orion constellation, it's a brilliant reddish-orange star that marks the upper left corner of Orion's distinctive rectangular shape. This striking appearance makes it a favorite for both professional and amateur astronomers. The star is one of the largest and brightest in the night sky, making it hard to miss. However, upon closer inspection, you'll notice that Betelgeuse doesn't remain constant in brightness. It fluctuates. This variability is typical of red supergiants, which experience complex internal cycles. Betelgeuse's massive size and advanced stage of stellar development set it apart from many other stars. Despite being located over 640 light-years away from Earth, making it relatively close in galactic terms, its immense size makes it an important target for study. While this distance may seem vast, consider this. If we could travel at the speed of light, it would still take us more than 640 years to reach Betelgeuse. Using even our most advanced spacecraft, the journey would take over 12 million years. Far beyond the scope of human history and current technological capabilities. The dimming of Betelgeuse isn't just due to its distance from Earth. Its intrinsic properties also play a key role. Known as a pulsating red supergiant, Betelgeuse undergoes expansions and contractions driven by the interplay of nuclear fusion and gravitational forces within the star. These fluctuations cause its brightness to change over time, making it appear brighter or dimmer. The star's brightness can vary dramatically, from a magnitude of 0.5 to as dim as magnitude 1.6, with periods ranging from 185 to 2,335 days. This variability has made Betelgeuse an ongoing subject of study, as scientists try to understand the forces driving these changes. In February 2021, Betelgeuse reached its lowest brightness in decades, igniting widespread interest and prompting various studies to explore the cause of this dimming. But brightness isn't the only remarkable feature of this star. Betelgeuse is also known for its distinctive red color, a result of its cooler surface temperature, around 3,500 Kelvin. This is much cooler than the surface of our Sun, which has a temperature of about 5,500 Kelvin. The lower temperature of Betelgeuse means it emits far less energy per unit area than the Sun, which is why, despite its size, it appears much dimmer to our eyes. The immense size of Betelgeuse, combined with its cooler temperature, gives it its characteristic red hue and sets it apart from hotter blue stars. These features make it a fascinating object of study, as scientists continue to unlock the secrets of this incredible star. Not unique to Betelgeuse, as they can also be observed on other stars, including our own Sunday. However, the star spots on Betelgeuse are particularly interesting due to their size, several times larger than Earth, and their ability to cover up to 20% of the star's surface, which is a remarkable scale. The existence of these star spots suggests that Betelgeuse may have a dynamic magnetic field, which plays a crucial role in shaping its outer environment and influencing its stellar winds. Stellar winds are streams of charged particles that flow outward from the star into space, carrying elements forged in the star's core. These elements are essential for the formation of new stars and planetary systems. Therefore, understanding Betelgeuse's stellar winds is vital for grasping the broader processes of stellar evolution and the creation of chemical elements. The stellar winds from Betelgeuse can significantly impact its surroundings, as they can carry away substantial amounts of material from the star's outer layers, enriching the interstellar medium with elements produced in its core. These elements can later be incorporated into new stars and planetary systems, contributing to the diversity of cosmic matter. Additionally, these stellar winds can interact with the surrounding environment, creating complex structures in space, such as shock waves and ionized gas regions known as H2 regions. These glowing regions often appear in areas where new stars are being formed. Betelgeuse's winds and stellar activity can have a profound effect on its environment, creating cavities and bubbles in the interstellar medium. These structures can influence the formation of new stars and planetary systems, ultimately shaping the development of galaxies on cosmic timescales. In summary, Betelgeuse is not only a fascinating object for astronomers to study but also a key player in the cosmic drama of stellar evolution. Its immense size, advanced stage of development, and dynamic behavior make it crucial for understanding the life cycles of stars and the processes that shape our universe. Located in the constellation Orion, Betelgeuse continues to captivate astronomers with its enormous size and dynamic behavior. This red supergiant is roughly 10 times the mass of our Sun and emits a distinctive reddish-orange hue due to its relatively cool surface temperature of around 3,500 Kelvin. Despite its lower temperature compared to hotter blue stars, Betelgeuse still radiates tremendous energy, although its brightness fluctuates significantly over time. One of the most intriguing aspects of Betelgeuse is its variability in brightness. Like many red supergiants, Betelgeuse undergoes periodic pulsations driven by complex internal processes. These pulsations cause its luminosity to fluctuate on timescales ranging from months to years. Astronomers have observed Betelgeuse's irregular dimming and brightening, with some recent instances of significant fading sparking considerable interest and speculation. These brightness fluctuations are not just a matter of light intensity, they also signal major changes occurring within the star. These changes are driven by Betelgeuse's advanced evolutionary stage. Having exhausted its core hydrogen fuel, Betelgeuse is now fusing heavier elements like helium and carbon in its core. This nuclear fusion process produces the energy that powers the star and sustains its enormous size. Despite being more than 640 light-years from Earth, Betelgeuse has a profound impact on our understanding of stellar evolution. Studying Betelgeuse provides valuable insights into the fate of massive stars, including how they evolve and ultimately end their lives. While Betelgeuse is currently in its red supergiant phase, astronomers anticipate its eventual demise in a spectacular supernova explosion. The prospect of Betelgeuse undergoing a supernova is both thrilling and daunting for astronomers. A supernova from Betelgeuse would be visible to the naked eye on Earth, potentially shining as brightly as the full moon for weeks or even months. Such an event would provide an unprecedented opportunity to study the dynamics of a supernova up close and gain insights into the formation of elements essential for life. In addition to its brightness variability and impending supernova, Betelgeuse also exhibits intriguing features on its surface. Observations from telescopes such as the Hubble Space Telescope and the Atacama Large Millimeter/Submillimeter Array (ALMA) have revealed complex structures and features on Betelgeuse's surface, including enormous convective cells, massive star spots, and even a mysterious plume of gas extending from its atmosphere. The convective cells on Betelgeuse are colossal, with each cell surpassing the size of Earth. These cells contribute to the star's pulsations and fluctuations by transporting heat and energy from the core to the surface in turbulent motions. Meanwhile, the star spots on Betelgeuse's surface are similar to sunspots but on a much larger scale. These cooler areas are thought to be regions where the star's powerful magnetic field prevents hot gases from rising to the surface, causing localized cooling. The discovery of these star spots has prompted astronomers to refine their models of how magnetic fields affect the behavior of massive stars. Additionally, Betelgeuse's extended atmosphere, as observed by ALMA, shows a gas plume extending from the star. This plume is likely the result of the star's pulsations and convective movements, which push material into its outer layers and beyond. Studying this gas plume offers clues about the processes that drive Betelgeuse's variability and the eventual fate of its expelled material in interstellar space. The scarab-shaped, rosy-toned Betelgeuse is a monster that remains humble despite its vastness. It doesn't need to flaunt its massive size to feel significant. While its tranquil shine in the night sky may seem misleading, it belies the immense energies at play within. Don't be deceived by its calm appearance. Betelgeuse is a colossal star, about 20 times the mass of our Sun. This enormous size is one reason it has been the subject of intense study for centuries. Its mass and developmental stage make it crucial for understanding cosmic physics. Betelgeuse has been a prominent feature in the night sky, first identified by the ancient Greek astronomer Hipparchus. Its name, derived from Arabic, translates to Orion's armpit, reflecting its position within the constellation. Although knowledge of Betelgeuse was limited back then, modern telescopes have allowed scientists to study this celestial body in far greater detail. Advances in observational technology have provided new insights into the star's complex structure and behavior. By analyzing the light emitted by Betelgeuse, astronomers have been able to determine many of its properties, such as its size, temperature, and composition. The Hubble Space Telescope, for example, has captured detailed images of Betelgeuse's surface, revealing intricate patterns of gas and dust. These observations have enabled researchers to develop models that help explain the star's behavior and predict its future evolution. Betelgeuse has also been studied with the Atacama Large Millimeter/Submillimeter Array, ALMA, a cutting-edge observatory located in Chile. ALMA has provided high-resolution images of the star's outer layers, offering further details about its structure and behavior. These advanced instruments continue to enhance our understanding of this celestial giant. One of the most remarkable discoveries made by ALMA is the detection of a vast plume of gas extending from Betelgeuse's surface. This feature is believed to be caused by pulsations within the star. These pulsations, driven by convection, where hot gas rises and cold gas sinks, create waves that ripple through the star's atmosphere, causing it to expand and contract. This dynamic process contributes to the star's variability and complex behavior. Thanks to the Hubble Space Telescope, astronomers have also captured detailed images of Betelgeuse's surface, uncovering intricate patterns of gas and dust. These findings have allowed scientists to refine their models of stellar behavior and better predict how such massive stars will evolve. Betelgeuse's surface is also marked by dark spots, known as star spots or magnetic spots. These areas, where magnetic forces are particularly strong, are cooler than the surrounding surface due to the star's magnetic field restricting the flow of gas from the interior. These star spots provide valuable insights into the magnetic activity of massive stars. Betelgeuse's magnetic field is believed to be many times stronger than that of the Sun, and this powerful field traps gas on the star's surface, forming magnetic loops or arcs. These loops can extend far into the star's outer atmosphere. In conclusion, Betelgeuse's enormous size, dynamic behavior, and complex magnetic field make it an object of great interest in the study of stellar physics.